Uh, First, let's click on the blue button to create new project. If you've got more than one Unity version, you will see it here, but as I've got one, you just downloaded your first version, it can stay as the default. Here we can choose the template for our project. We will use this 3D built-in render pipeline because it's the most universal, and in most of the cases, it just works best. Uh, at the right side of window, you can name your project. And after you name it, we can click on the create project button. Unity will copy that template into location uh, that you chosen, and will copy the and will start. Can take, depending on your computer's specification, from 15 seconds to about 1 minute. And we will start with the most basic scene. Okay. Everything. While the project is being created and Unity is trying to open it, let's just go through what you can see in the editor window. So at the left side, you can see the scene hierarchy. It's basically all the visual and logical elements that we put in. Right now, we've got scene name example scene, and in it, there is a main camera and directional. Uh, as you can see, the main camera component, the main camera object has transform as all objects in has to have, and it has its own component camera. Uh, and as you see on the projector, while I click the different objects in hierarchy, first of all, in the main part, you can see that the gizmo for transform is changing. And second, the inspector at the right side is also changing. Inspector is basically like properties for the object that we have chosen. Uh, at the bottom of window, we can see the project window and the console. Project is basically the files that we have in our project. So the so-called assets. It can be everything from the music files, textures, models, scripts, and so on. And in the central part of our window, we've got the scene view, and at the other tab, I've got the game view. The scene view is general view that we use to see what is in our scene. And in game view, we've got what our camera is seeing right now. Once your projects are created, we will create some two simple objects, and we will go through the manipulation tools that we've got here. And also, we'll go through how you can operate in Sunview. Okay, let's start with pressing the right button in the hierarchy and choose 3D object cube. Right button, and here we just choose cube. Okay, if you use scroll, you can zoom in and zoom out in the sun view. Yeah, if you press scroll and drag your mouse, you can pan the view. If you press right mouse button, you can look around. If you press right button and W key, you will go forward, S is backward, A and D left and right, Q and E up and down. Yeah. Right now we have added the first primitive object, the first cube, and as you can see in the inspector window, it has transform, it has a mesh filter that informs what kind of mesh it has, the mesh renderer that is responsible for the visual properties, and box collider. We'll get into colliders later, but first let's focus on the transform because all objects in scene has that parameter. The position, rotation, and scale are in the Euclidean system. So we've got three axes, x, y, and z. We can either change the position value of axis here, or we can grab this while having the move tool selected. We can grab this axis, move the cube. Pretty straightforward, yeah. Later we've got the rotate tool, and if you rotate this cube, you will see that the rotation is changing in the inspector, yeah. Depending on the axis that you choose, the value will be different. Later we've got the scale tool. If we choose one axis and scale, we can scale in that axis, or we can click in the middle and scale all axes at the same time. Later, we've got the direct transform tool. If I choose this tool and get, for example, this view, I can transform this 3D object like it was an 2D object. Yeah. So basically, I'm carrying at the same time. If you look at the position is also changing so that the so it's matching the middle of the object, the pivot point, to what we can see in the screen. Okay, we have created our first object. We can create also, and if we go into scene view, in my case, I can see just that object. Maybe I will rotate it a bit so that's a little bit in a better perspective. Okay, now if I don't like the changes that I made, in the transform component, I can click on the three dots and choose reset to get the object back to the default state. Okay, now let's add another object. It will be plane. So 3D object and plane. In the scene view, please position the plane below this first cube, so that you can see the shadows that it's producing. If they are too far from the camera, you can also grab them, and the scene view, we can see where is the camera, where is it looking. So we can just grab both of them with the control, yeah, and drag them a bit closer so that we can see them better. Okay, in the top part of window, we've got the play mode buttons. So we can play our scene or our editor application. We can pause it if we want to check something. And when the play mode is on, we can go just select pause and just go one frame further. But right now, if we click on play, the application will start, but nothing is happening, yeah, because we didn't include any scripts or any components that can affect objects in our scene. So we are just viewing the static image from the camera. But as we are in the inspector, we can in play mode choose the directional light object, and if we change the rotation of it, you can see the changes in the window in the game view. But if we now press play again to exit the play mode, the rotation of directional light goes back to the to how it was when we first hit the play button, yeah? Because all the changes that we do in the play mode aren't saved unless we change material directly in the asset. Okay, so now if we want our cube to be affected by physical system, so for example, if we want it to fall down, we need to choose that cube and select add component at the inspector window, and we can either go to the physics and rigid body and find a component called rigid body, or just right here rigid body. Be sure to choose the rigid body, not the rigid body 2D, because 2D is just for 2D applications. Okay. In the rigid body component, we've got its properties, such as mass of object. Here in the rigid body, we can now choose play once again, and the object. Okay. So now, thanks to the rigid body component, our cube can fall, yeah, because it's got the gravity enabled. But the plane, which doesn't have the rigid body, is acting like an static object. Yeah. So it stops our cube from falling down because it's got its now own collider, but no rigid body component. Yeah. Okay. So right now our cube is falling down because of the physical system, but we can also control how the object moves using the scripts. So let's create another cube, 3D object cube, or it can be other shape if you like, for example, capsule or cone, but I will choose another cube. Yeah, and position is somewhere here. Okay, we can create a simple script that will rotate this second cube. So first, let's create a folder in the assets so that our project don't get too messy. So right click in the assets, create, and at the you don't see it. At the top there is folder option. So click on the folder and name the folder script. Okay. Once the folder is created, let's get in the folder. Now, once again, we should choose create, and this time we will choose C# script. After selecting that, we can name our script. Let's call it the spin. Okay. Once the script is created, you can see in the inspector that inside the script file there is a public class that derives from monobehavior. That means that the monobehavior are basically uh, referable. Yeah, they use specific functions such as update, on enable, on start, on destroyed, and the classes created that way can be assigned to any object. If we now double click it, it will open in your IDE. So in my case, was Studio, and should open. So okay, first of all, as you can see, the spin class derives from monobehavior. Yeah, in the class there are already two methods: start and as you can see in the comments it is called before the first frame, and update is called once per frame every frame. Let's create a first variable in this class, and let's name it in value. So it will be variable of type float, and let's name it spin value. Okay. If it can be either private or protected, that's your choice. In general, I try not to use private variables. In most of the cases, I use protected because I am never really sure if I want derive from that class, yeah, and I want to have access to that variable. Okay. If we save now and go back to Unity, you can see that Unity is compiling, and after the compilation is done, we can assign that script to the cube that we created. We can do it in two ways. Either we drag and drop it from assets to cube, or the other method is that we choose add component, enter the name of our class, for example, this our spin, and assign this way. But right now, yeah. So right now, even though we declared that variable, this variable called spin value, in the Unity, after assigning the script here, the value isn't exposed. So we can't value, we can't modify it, we can't do basically anything. So we could make the variable public, but it's generally not a good idea to make too many variables public. So to expose it to the Unity editor, we can write serialize field, and after adding that parameter, we can save. We go back to the theme. You can see the variable is exposed in the editor. Yeah. So right now I can change its value, but the script doesn't do anything right now. So let's go back to the Visual Studio and make it do something. So if the name of the class is spin, we've got the spin value. Let's make it so that this script is objects to which it's assigned. So first we have to reference the object that we want to modify. So we could write this now next transform, so that we are referencing the same object. And after that, we can either modify, for example, the Euler angles. That means we will modify the rotation, or we can use the function rotate. And define, as you can see, there are a few overloads because we can choose either how much do we rotate. We can define that here's the axis, then the angle that we want to rotate. We can define how many degrees in each axis. Yeah, we will choose the one in which we define axis and then the value. So first, to define the axis, we can either use an reference, or we can use Unity specific function. That means I mean vector 3 up, that will be the up axis, and now the angle. So if we use just the spin value, depending on how many FPS we've got, that many times the object will rotate. We want to make it so that it rotates at constant value per second. So we will use spin value times time delta time. Delta time is amount of time that passed since the last frame. Yeah. So that way it can be dependent of the time. Yeah? So each frame, each second, it will rotate that spin value. Okay, now it's safe one, and go back to the Unity. If we press play, as the spin value is 0, it still won't rotate. If we define spin value as, for example, 60, you can see that the object rotates degrees per second. Yeah? And if we change the values, yeah, it rotates at different rates. If we choose minus values, yeah, the object rotates in other direction. And if we if we put 0 here, it's okay. Now we've got 2 cubes, and aside from the fact that they act differently, they basically look the same. Everything is gray and it doesn't look very attractive. So once again, in the assets folder, the assets part, let's create folder, create folder, and let's call it materials. Yeah. Okay. After creating the folder for materials, let's get into that folder. And once again, let's create a new thing. In this case, we will create material. It should be somewhere in the middle of create menu. So let's create material. Okay. If we choose create material, we can name that material, and let's call it, for example, red, red, so that know that it's red. And right now, this material, as you can see in the thumbnail and the small preview here, is white. Why is it white? Because the albedo value white. So if we want to change it, change the color, we can press on the on that white area and choose the color that we would like. For example, red. We can also change the values of properties such as metallic and smoothness. And here in the preview, you can see how the object should look. Yeah. Now we created this first simple material, but it's still just in our assets folder. How can we assign material to an object? There are 2 methods. First method is in the scene view. Grab the scene view. We need to grab and drag the material to the object, or we can choose an object, for example, this cube that will be rotating. In the inspector window, at the component called mesh renderer, let's expand the materials that are assigned to an object, and we'll have to assign this red material. Yeah, but if we look at the game view right now, this doesn't look like what we expected. Yeah, because well, maybe I will change metallic a bit, but still there is a clear difference between this and this. Why is it? Because here in the preview, we are using the reflections, and right now our screen doesn't include any information about the reflections, about environment, and so on. So let's fix it by adding uh, object that will gather the data about reflections. It's in the light section, and it's called the reflection probe. Once added, we can see its properties. So as all objects, it has its position, but it has also the reflection probe component. For now, let's change the type to the real time. In the settings section, you could choose what is the box size. So how many objects will be, what area will be considered when gathering the reflections, resolution of reflections, and so on. But right now, let's stay at the default values, and we can see that started looking a bit better. If we now choose our directional light and choose the other direction, so change rotation a bit, we can see that it changes. It's both the reflections and the shadow are changing, and it looks much more natural than without the reflection probe. Yeah. Okay. Till this point, we were using the primitive objects that can be created in Unity from primitives. Now, in materials to in materials to the course materials from your speaker to the lesson 2, you've got a car Unity package. That is a package created by me for these classes. So please download it, and as I've got it already downloaded, I will show you how to import this package and how to operate. Once the package is downloaded, you can either choose window, asset management, import package from disk. But to be honest, I think that the faster method is just to drag the package into our assets and click. So once the package is imported, we can see that there is. I will just. Once the package is imported, I can drag their file in, and as you can see, we've got here. We can move it a bit and maybe rotate view from the side here and here. As you can see, the car has an arrow next. If we click it, we can expand the structure and see that it has many elements. Some of them are consisting the mesh filter and mesh renderer components, in which there is some data about the mesh of the object, yeah, and materials that are assigned to that mesh. If we press on the press on one of the materials, I will. Yeah, if we press on this, you can see that this material and we can dynamically change the color and observe how that affects the look of our car. Yeah. As you can see, all instances of that materials are affected. Uh, if we choose change the metallic parameter, the paint on the car, as you can see, it's changing. The same goes with the smoothness. So using that, we can really change the look of the material, and uh, we've got also here the parameters that we didn't use till now, such as normal map, height map, occlusion, and detail map. Normally, those maps need to be prepared in some kind of outside software so that the properties are best. But now I will just go to the, oh, not driving wheel, with standard. Okay, and here we have the material for the Tokus wheel. Uh, I will just go into scene view so that you can see it better. Okay, we've got material that has normal map. The normal map forms, oh, at the projector it's doesn't really uh, if we change the value of normal map, how much it should affect, you can see that it changes. Changing can use it add some structure to our model. Yeah. Okay. The one that we are not using right now, uh, maybe I'll show it back on the this body. Yeah, yeah, yeah. Oh, yeah, no problem. Yeah, yeah. I will upload the screen recording, and you can watch it from home. Okay. We've got also the emission parameter of material. Right now, black, and we don't have any map assigned here. But the emission is just the, let's say, inner light of an object, the light that the object, that the material itself emits. If we change it from black to something like red, yeah, you can see on the screen that that the car starts to glow at all the surfaces. In many cases, we don't want it to go like that from all surfaces, but we want to choose the area to glow or part, for example, to have the neon light effects. How we can do it? We can do it by assigning the map here to the, oh, would be totally black. Yeah, by assigning map here, in case of emission map, the map defined it that way that the white parts will glow with the emission color, the black parts won't. So I will just open the paint and create a simple texture that I can put in a project. Okay, so maybe something like this. I know that it doesn't look good, but it's just to demonstrate. I will choose to save it in the project folder. Yeah, yes, maybe test emission. Yeah, got this texture here, the one that I created a moment ago. And here in the color section, I can click on this dot and choose the texture that I just up. Yeah, and as you can see, in these places that there were white lines, I can add horizontal lines. How the texture is placed on the mesh defined in most of the cases in the software such as Blender, 3ds Max, and so on. Unity, we usually don't modify those maps, yeah, AV maps, but we can do it, but not very convenient, yeah. It's a lot easier to do it in the Blender or okay, and if we don't like that effect, we can turn off, yeah, or just turn off the emission, or just assign map, and won't uh, and it won't affect the material anymore. Okay, uh, right now, uh, so right now this object, this cube, rotates around its up-axis, but what if we want it to rotate around some different point? We can either write another script that takes as a reference some other transform around which it will rotate, or we can play around a bit and create this object in scene and assign our script there. So first, let's create new empty object. Let's name it rotate center. Now, from this cube, we can remove the spin script so that it doesn't rotate by itself. Assign it back to the rotate center and put cube inside that rotate center. So drag and drop the cube from the general hierarchy under the rotate center. Yeah, so right now that is parent, that is child. And if we define the spin value as, for example, 120, press play, we can see that the cube is rotating around point because this object, the parent, rotating, and side object has to keep its local position according local position, so it rotates in whole scene. Yeah? Okay. Right now, the in script have spinning from the start of the scene. We can make some mechanism to start and stop this rotation. So to keep it as simple as possible, let's edit the spin script once again. Let's add boolean so that we know if the object should rotate. Next, let's execute this rotation only if should rotate is true. So just a simple condition. Okay, and want to do the on and off rotation basing on the user input. So for example, let's make it so that when user presses, for example, space, the root rotate will change its value. Okay, so we create another condition if input. So we might get to the input system, Unity input system, get k down, so that we get the value from keyboard. Later, we need to define which k do we want. IntelliSense is suggesting escape, but I will choose space. So if the user presses the space k, we want to change the should rotate to the other value, yeah, so that it acts as an toggle. Yeah, I should, if that is private bool, I should use small letter, but that's the only. Okay, now if we save it, go back to press play, you can see that the cube isn't rotating, and if I press space, it starts. One more space, press start, stop. So here is a really simple toggle, yeah, that can affect execution, uh, and also you can see that you can see how we can access basic Unity input system. Yeah? Okay, everything working or so? Basically, during classes, we went through the creating projects, adding some simple the rigid body. We created our field scripts. We affected look of the materials. We accessed the input system, and for the first contact with that base, basically all.